Why are railway tracks surrounded by thousands of grey stones? They may look like ordinary rocks, but without them, most conventional railway track would quickly lose its correct position. These stones are known as railway ballast, and they perform several important jobs every time a train passes over the track. A railway track is not simply two steel rails placed on the ground. The rails are fastened to sleepers, and those sleepers sit inside a carefully constructed bed of ballast. When a train passes, its wheels apply enormous repeated loads to the rails. Those forces travel from the rails into the sleepers, through the ballast, and into the ground beneath the railway. The ballast helps spread those loads over a wider area. Without a strong and stable track bed, the sleepers could sink unevenly and the track could gradually lose its correct shape. Ballast also helps hold the sleepers in position. Railway track must remain at the correct height, alignment and distance between the rails. Even small changes in the track's position can affect the quality of the ride and may eventually require maintenance. The mass of the sleepers and surrounding ballast also helps the track resist sideways and lengthways movement. This is particularly important on continuously welded railway track, where changes in temperature can create large forces inside the rails. But supporting the track is only part of the ballast's job. Rainwater must be able to drain away from the railway. The gaps between the stones allow water to move through the track bed instead of collecting around the sleepers. Poor drainage can weaken the ground beneath the railway and make it harder for the track to retain its correct position. Railway ballast is made from graded crushed stone rather than loose soil or ordinary decorative gravel. It creates a firm track bed while still allowing engineers to adjust the position of the railway. Over time, repeated train movements can cause parts of the track to settle. Engineers can correct this using a machine called a tamper. A tamper lifts the track and inserts vibrating tools into the ballast beside and beneath the sleepers. The machine then moves and compacts ballast underneath each sleeper to restore the correct height and alignment of the track. Ballast regulators can then redistribute and shape the stones around the sleepers. This ability to lift, move and correct the track is one of the major advantages of conventional ballasted railway. However, ballast does not last forever. Over time, the stones can wear down and the gaps between them can become contaminated with dirt, fine material and other debris. This can reduce drainage and make the ballast less effective at supporting the track. The ballast may then need to be cleaned, redistributed or completely replaced. Not every railway uses ballast. Some lines use slab track, where the rails are supported by a rigid concrete structure. Slab track can require less routine adjustment, but it is generally more difficult and expensive to alter once installed. For much of the railway, traditional sleepers and ballast remain a practical and highly effective system. So the stones beneath railway tracks are not simply there to fill an empty space. They support the sleepers, spread the forces created by trains, help hold the track in position, allow water to drain and make it possible for engineers to correct the track when it settles. The next time you look down at a railway line, remember that the rails are only the most visible part of the system. The stones underneath them are helping to keep the entire track in the correct position. Subscribe to Trackside Explained for more clear explanations of how Britain's railway track really works.